Okay, guys. Today we'll see modularization techniques in SAP ABAP. So, what is the meaning of modularization? Modularizing means
Mm.
breaking a complex business logic into reusable blocks or reusable units. Okay, dividing a complex business logic into reusable modular units or reusable blocks.
Yes, sir.
So, the definition will be like this. Okay, or modular units. So by using modularization technique, we can design a complex
Representative.
business logic into reusable blocks or modular units. So how it is different from our previous examples, whatever the programs we created earlier, how like these modularization techniques are different. So if you observe in our previous programs, we have included all the business logic in the program itself, right?
Sir.
Whatever the validations, whatever the uh, data selections, data display, everything we kept only on the main program, right?
Yes, sir.
And if we have any similar functionality, if we need any similar functionality to be implemented in a different program, what we need to do? We need to create that program from the beginning with the same logic, whatever we implemented in program 1, right? Let's assume program 2 also there is some common functionality which we are using in program 1. If you keep all your business logic in the same program, if you don't use reusable modular units, can you reuse that
Mm, sir.
business logic in program 2? No, right? To make it reusable. So what do you mean by reusing the business logic? If you have any similar requirement in another program, you don't need to create it from beginning. Let's say you implemented 100 lines of code for some calculation in one program, and we need similar calculation in program 2. Then what we need to do? We need to create all 100 lines, right, in program 2 also to achieve the same logic or to achieve the same functionality. What if we can reuse the logic whatever we implemented in program 1 in program 2, so we can avoid all that 100 lines of code, right? We can save the time, right?
Yes,
Also,
sir.
whatever the functionality we implemented in program 1, that is tested and confirmed that that is working properly, that calculation is working properly, right?
Yes, sir.
So without any doubt you
You
can
can use
use it in
technique.
other applications, other programs, right?
Yes, sir.
Because it is already a proved solution, right?
Yes, sir. Understood.
In some other application, if you are using it Here also that should work fine. But if you start creating from the beginning, there might be some issues, there might be some errors, right? When you are
Yes, sir.
creating from the beginning, you might forget to add some statements, right?
Yes, sir.
Also, what is the other important thing? You are writing a duplicate code in the system, right?
Yes, sir.
You are implementing same functionality again and again. You are writing same duplicate program, same duplicate code, right? We can also call the redundant code, redundancy. That is also the synonym of duplication, right? So by using modularization techniques, you can achieve reusability of the existing logic, and also you can avoid code redundancy. What is code redundancy?
Using same code repeated time.
Yes. So implementing the same code in multiple applications, right? That is called code redundancy. What is readability? Better readability. Readability means when you open the program, it contains 1,000 lines of code. It is not very convenient to understand the business logic. Okay? If you split that complex program into reusable units by functionality wise, one functionality you are going to implement in one modular unit. The other functionality you are going to implement in another modular unit. For example, for validation, you are going to create one modular unit. For a data selection, you are going to create one modular unit, right? For data display, you are going to create one different modular unit. So it will improve the readability of the program. You can easily understand the program business logic, right? What is
Yes,
the
sir.
other advantage of using modularization techniques? It eliminates
Errors.
code redundancy.
Code.
Redundancy nothing but duplication code, duplicate code. Okay,
Okay, sir.
it will improve or it will avoid the code redundancy, and also it is easy to maintain the code. Okay, so these are the advantages of using modularization
Realization
techniques.
techniques.
Okay, now let's see what are the different modularization techniques available. First one is subroutines. Second one is include programs. Third one is function modules. Fourth one, class methods. Okay, so these are the modularization techniques available in SAP ABAP. Okay,
Sir.
so modularization will looks like this. If you assume this as a application, so you're not going to create the entire code in the same program. What you are going to do, you're going to make it as modularization blocks. Now you are going to call these modularization units in the program. Depends on the requirement. Application 1. If you have a different application, let's say we have application 2. Now I need only the specific logic. So I can call only those modularizing units. What are these? Modular units. So you can build the functionality by reusing these modularization units in any number of applications. Okay, clear?
Yes, yes. Okay.
So these modular units can be a subroutine, include program, function module, or
Class method.
class methods. So subroutines, include programs, and function modules follows a procedural programming approach, but class methods follows object-oriented programming. Okay. So what type of programming it is? What type of programming is ABAP? Is it procedural oriented programming or object oriented?
Procedure oriented.
It supports
Object
both actually. Okay.
Oh, okay, sir.
So it will support procedural oriented programming, like depends on functions, right? And object oriented programming. Okay. We can write ABAP applications in procedural programming and object oriented programming. So in these days in the projects, so most of the projects using object-oriented programming because of its
Yes.
advanced features. Can you tell me few languages with procedural programming approach? C. C
See,
programming is procedural programming where we have all functions. Okay.
Yes.
Can you give me one example for object-oriented programming?
Java.
Yes, Java, C++. These are all object-oriented programming. Okay.
Yes.
okay, sir.
Now let's see one by one. So as I said, subroutines also used for modularization, but in these days mostly using class methods and function modules. Okay, but we'll see each method one by one. First one, subroutines. So subroutines are these are local to the program. Okay, we cannot reuse the subroutines in other programs. Okay, we can reuse. Okay, so subroutines can be used only within the same program, cannot call in the other program. So how to call the subroutine? For this we use to call the subroutine we use perform and subroutine name. To define the subroutine we use form and end
End
form.
form.
And here in between the definition, subroutine definition, we are going to implement the business logic. But to call the subroutine, what we need to use? Perform. Okay. And if you want to pass any inputs, we need to use using p underscore val space p underscore val2. Like that, you are going to pass the inputs. Anyway, using is optional. Using and changing also there. They are optional. Depends on the requirement. Okay. If we need to pass the inputs to the subroutine, we need to use using parameter. Let's see one example. So create the program. Looks like 2021 is slow. Let's try in 2020 server. Let's take two parameters. Now the calculation I'm not going to create in the main program, but I'll use a subroutine. So how to define a subroutine? Form
Subroutine.
subroutine name. For example, add numbers and form. You can do like this. Here data of lv underscore output equal to p underscore val plus val1. So this is subroutine definition, and there is one rule you should follow. Subroutine definition, this form and end form should be the last statement of the program, right? You cannot include form and end form in between any statement. For example, whatever the statements after this form and end form, they cannot be accessible. They are not executable. Okay. So whatever the statements you implement after form and end form, those cannot be executed. So all the executable statements should be before form and end form, before all the subroutine definitions. Now tell me how to call the subroutine. Perform.
From subroutine name.
So enter some inputs. So this is the output. So now we are doing that calculation in subroutine. So if you need to call the same logic again, what you need to do? Just call this perform again. Now let's see how many times it will execute. 10, 30. How many times it is executed?
Two times.
The same business logic is executed for 2 times. Okay.
So,
So but subroutines can be reused only within the same program,
um,
right?
same thing.
You cannot
Yes, sir.
use the subroutines in a different program. Okay, these are local to this program. Okay.
Yes, sir.
Whatever the functionality you need to reuse for multiple times within the same program, you can use subroutines. Okay.
Okay, sir.
Now, are we passing any inputs to these subroutines? Are we passing any inputs to this subroutine? No, we are just using these global parameters to do the calculation and display the output. We are not passing any inputs. How to pass
Inputs.
the inputs? Like this. Let me remove this, or I'll comment this, right? So creating subroutine in a different way. First create the perform add numbers. We have inputs now using what are the inputs? P underscore val and space P underscore val1 and output should be returned to changing some lv underscore output. Let's define this output here. Define the output parameter here or variable here. Type I. Now double click on this. Double click on the subroutine name. Is this subroutine available? Add numbers. I've commented this anyway. Is this available? No, right?
No, sir.
To create this subroutine, double click on it. So here what I am doing by using keyword, I am passing the inputs. By using changing, I am returning the output. Double click on this. Double click on this to create the subroutine. Yes. So do you want to create in the main program or do you want to create the include program? Include programs we'll discuss in the next example. But observe here, select the main program. Subroutine definition is created, right? Using parameter 1, parameter 2 and output will be returned to parameter lv underscore output. Now do your calculation. Use the same names in the definition or you can also change these names. You can, if you want, you can also change these names. Equal to p underscore val plus, you can just copy and paste. Okay, check the syntax. Display the output. Or we'll use a different subroutine to display the output. Perform display output using, I'm passing only one input, that is whatever the data I need to display, using
Out.
lv underscore output. Create one more subroutine. Double click on this. So in the standard programs, right, you can observe hundreds of subroutines. If you see any standard program available for MM01 or VA01, ME23 and this kind of standard reports, right, you can see hundreds of subroutines because they have implemented years ago. Okay. Now whatever we are designing, whatever the new applications we are creating, we are using mostly object oriented ABAP. Okay. But to work in the support projects, you should understand subroutines also. So use write statement to display the output. P underscore lv underscore output. If you want, you can also change this. I'm changing like this. P underscore output. Now we have two subroutines in the program. Let me remove this. So I'll write one statement after this. Some select single star from Mara into w underscore Mara. Is it going to work? What it is saying? Statement is not accessible because what after the subroutine definitions, we cannot write any executable
Okay.
statements. Okay, you can only keep before the form and end form. Okay,
Yes, sir.
okay, it will display the output. If you keep a breakpoint, or if you want to pass a different inputs, you can pass like this, some 10 or maybe 30, remove the values, hard 30, provide one space, and 40. Okay, I will repeat output display also for the different calculation. We keep a breakpoint. Passing the values, output is calculated. Next subroutine is executing, it will display the output. Next subroutine is executing, updated the value. Next subroutine is executing, display the output. This is how we can use subroutines. You can also write select statements, any logic inside this form and end form. Okay, clear? But these subroutines are local to the program. Now, there is one more modularization technique. Now, what is the next modularization techniques? Include program.
Include program.
So let's see how include program will work. So before that, so include programs cannot execute independently. Okay, so include programs cannot be executed independently. So what are the program type we are creating as of now? In SC38, we are selecting SC38 executable programs. So these executable programs can accept the input and return the output. So these can execute independently. But include programs cannot execute independently, can use include programs in other in any other executable programs, right?
Yes.
So you can implement some logic inside this include program, and you can reuse this include programs in different executable programs. Okay.
Okay, sir.
Now how to include the program in other programs? Include, for example, zdemo logic. This is how you can include the program in any other programs. But this cannot be executed independently. It won't accept any input. Okay. Accepts no inputs,
Not execute independently. Returns no output.
returns no output. It won't accept any input and it won't return any output. How can we create include program? Let's see here.
Improve program.
So if you observe these parameters are common to multiple programs. So in different programs also, I have a requirement to use same parameters with same type. How can I make it reusable? By creating one include program. How to create an include program? Go to SC38. There are multiple ways of creating an include program. Underscore top. Why I'm calling it as top? Because it is for declarations. Top declarations. Create the program. Remove the dot. Create the program. What type of program we should select?
Include program.
Include program. Click on save the local object. Now copy these declarations, paste here in the include program. Pretty printer. Activate the include program. Include program is activated. This is the include program name. So how can I add these declarations to the main program? How can I reuse? Using include and the program name,
Name.
right?
Yes, sir.
Also, if I want to pass some default values, this is to pass the default values, right? So how can
Yes.
you make this as a reusable block? So by using include program like this. So I'm using a second approach here, creating include program from the main program itself. Now previously I created in a separate session. Now here I'm creating from here itself. This is just for naming convention. I use init, double click to create the include program. Yes, save. So what is the logic I have to place here? Let's save this, double click on this, paste here, pretty printer, activate the include program, go back. So here include program is added. Okay. Now for validation also you can create one include program. For data selection or data calculations, you can create one include program. For example, include, I'll use same program name with some difference, underscore calc, double click, create the include program, one more include program, p underscore val1, pretty printer, activate it. Now activate the main program. Main program is activated. Now how many lines of code we have in the main program? Only few lines of code, right?
Yes.
All the business logic is included in this include programs, right? Now let's
Yes.
try executing this program. So these are your inputs, execute, this is the output. So we are using different modularizing blocks for each functionality. Now how can we reuse this include programs in a different program? Let me create one more program, include program 2. So create the program. Now how can I use the other include programs? You
Include.
can include on the program name in a different program, right?
Yes.
Initialization, include and the program name. Okay.
Okay.
So include programs are global. You can reuse in any executable program. Okay.
Okay.
In standard programs, you can see many include programs. Within the include programs, you can see subroutines, right? So we don't write code in the main program, all the code in the main program, because it is very difficult to understand the code, or even it won't support any reusability. Okay, clear?
Okay, sir. Sir,
So
initially we have to create through executable type, sir.
first we create the executable program.
Then after we have to include all programs
Huh,
by
right.
defining the same place.
Yes.
Okay.
So you can use include statement to add reusable code to your executable program.
Okay.
Okay. So
Okay.
it is not necessary to create include programs every time. Once you created it, in future, if you have any similar requirement, just use include space
Program.
that program name to add that functionality to your executable program.
Okay. Okay, sir. Okay, sir.
Okay.
Okay, sir.
So when you are using these reusable blocks, right, you should observe the data declarations. For example, if you declare something in the include program that is local to this include program, that variable memory may not be accessible outside of that include program. Okay. So we'll see that examples tomorrow, and the function modules also. It will take time to explain about the function modules and to create the function module. Okay, we'll continue
Okay.
the remaining modularization techniques tomorrow. So please practice or please. Earlier we created a lot of programs, right? Using data selections, validations.
Yes, sir.
Try to apply these modularization techniques on those programs.
Okay, sir.
Okay,
Okay, sir.
like creating a reusable include program for company code validation, like that. Okay.
Okay, sir.